Today we're going to take a look at the eccentricity of ellipses. And so eccentricity, why do we need it? Without a graph on hand, how would you explain to someone else how elliptical something is? So if you look at these three ellipses below, they're supposed to be labeled A, B, and C. A, B, or C, which one do you think looks most like a circle? I would say that A appears the most circular to me. B appears the most elliptical or elongated or oval. So how can we mathematically compare these? Because when scientists look at the orbits of planets, it's nice to say how elliptical or how close to a circle these ellipses are. So in figure A, the ellipse might easily be mistaken for a circle. In a circle, the foci are equal to the center of the circle. Therefore, when the foci are extremely close to the center, it is difficult to make a visual distinction between a circle and an ellipse. Early astronomers had a difficult time when studying planetary orbits whose foci were relatively close to their centers, and now we can use the concept of eccentricity. So eccentricity is the ratio of C divided by A. Remember that C is the distance from the center to a focus. And there are two foci in an ellipse. A is the distance from the center to the end point of the major axis. So let's think about this ratio. When C is really, really small, then C divided by A will be a really small number. And what we said was C is the distance from the center to the focus. So when the focus is really, really close to the center, C will be very small, and the eccentricity of the circle will be very small. When the focus gets drawn way out on the major axis, then C is going to be closer in value to A, right? C might be 4, and then A is the endpoint of the major axis, maybe that's 5. 4/5 is 0.8. 0.8 is a very large eccentricity, meaning a very elliptical ellipse. So it says, for an ellipse that is nearly circular, the foci are close to the center, and the ratio C divided by A approaches 0. So for a circle, the eccentricity is 0 because C is 0. C is on top of the center. For an elongated ellipse, the foci are close to the center. Wait a second. The foci are close to the center. Oops, the foci are close to the end point of the major axis. Sorry, typo. And the ratio C divided by A approaches 1. Eccentricity can never equal 1 because then you'd basically have a flat ellipse, right? If this is your center, if C and A were equal, then you basically would have a pencil-thin ellipse. So eccentricity will be between 0 and 1, and it could equal 0 if it's a circle. So we're just going to do a couple practice problems to find eccentricity. Remember the relationship A squared equals B squared plus C squared. We're going to need that Pythagorean identity to find C. Here's my first ellipse. I want to know which of these ellipses is more eccentric so that we can compare them. So my center for both of these ellipses is at 0, 0. We don't really care where the center is. We're interested in the A value. So for this first ellipse, A would be 3 and B would be 2. Remember, A squared is always the bigger number and B squared is always the smaller number. In this example and this example, it just happens that A squared is under the X squared term, but they could be interchanged. All right, so I'm going to set up, I know that A is 3, I have to find C. A squared equals B squared plus C squared. So I'm plugging in A squared and B squared in my equation. Subtract 4 from both sides. C squared has to be 5. So when I take the square root of both sides, the square root of 5 is just 2. The square root of 5 is 2.2. So they want me to take C and divide by A. So 2.2 divided by 3 comes out to 0.73 repeating. So the eccentricity of ellipse A, that's pretty elliptical, right? Because an eccentricity of 0 is a circle, and an eccentricity close to 1 is a very elliptical ellipse. Okay. Example B. A is going to be the square root of 20, and B is the square root of 15. And if I do A squared equals B squared plus C squared, C is going to be the square root of 5 again, isn't it? Just a coincidence, but C came out to 2.2. What is A this time? So the square root of 20 is 4.47. So I'm taking 2.2 and dividing by 4.47, and I get 0.49 this time as my eccentricity. So which ellipse is more eccentric? This ellipse is more eccentric. It's more elliptical than this one. This one would be closer to a circle. So, I mean, it still has an eccentricity of 0.49. So it's still going to be elliptical, but not quite as elliptical as ellipse A. So that is eccentricity.